hold on. गाइस यूट्यूब ने मेरा बहुत दिमाग ख़राब किया है. I wanted to stream on my iPad so that I could see your chats on my phone. क्योंकि मेरे दोस्त ने बोला कि I was in your live and you did not say hi. I said hi. So I don't know why it was not working on my iPad. और अब मेरे फ़ोन के साथ perfectly fine चल रहा है, तो क्या करूँ? Okay, I was in your live and you did not say hi. I said hi. So I don't know why it was not working on my iPad. और मेरे फ़ोन के साथ perfectly okay चल रहा है. We're going to be studying neurophysiology again. अभी मैं कॉलेज से आया था 4:30 बजे. फिर जिम के बाद नहा के फ्रेश होके अभी मैं पढ़ने बैठा हूँ. एंड आज का टॉपिक मैंने थंबनेल में न्यूरोफिजियोलॉजी लिखा है, लेकिन एक्चुअली मुझे तीनों सब्जेक्ट पढ़ने हैं. तो 50 minutes आई एम गोइंग टू स्टडी न्यूरोफिजियोलॉजी एंड आई हॉप ऑन टू बायोकेम और एनाटमी, क्योंकि उसका थोड़ा आधा घंटा पढ़ के मैं उसको ख़त्म कर दूँगा, क्योंकि आज जो पढ़ा है हार्ड टू रिवाइज इट. बट मेजॉरिटी ऑफ द चंक विच आई विल बी स्टडिंग टुडे इज़ न्यूरोफिजियोलॉजी, बिकॉज ख़त्म ही नहीं हो रहा है ये तो. ऑल्सो आई होप द फैन डज नॉट बॉदर यू. बहुत गर्मी है दिल्ली में. सो ओके. सेंसरी सिस्टम पढ़ना है. ऑल्सो आई विल लुक इन टू हाउ पीपल डू लाइव स्ट्रीम. लाइक मुझे आता था पहले, नीट के टाइम में मैंने किया है ऑब्वियसली, बट अब मैं भूल गया हूँ क्योंकि कैसे OBS चलाना होता है, कैसे हाउ डू यू लिंक द डिवाइसेस एंड हाउ डू यू पुट अ टाइमर, हाउ डू यू डू ऑल दैट पोमोडोरो थिंग. आई न्यू हाउ टू डू इट बिफोर, बट नाउ भूल गया मैं ये सब. तो आई लुक इन टू इट एंड विल क्रिएट अ वेरी homely live where I'm not the only one speaking. 1 घंटे से I realized it yesterday कि मैंने बहुत ज़्यादा बोल दिया था पिछले लाइव में. So I have to let other people also study. So we're going to study sensory system today. मैं मोटर और सेंसरी के बीच में जंप कर रहा हूँ, क्योंकि there is something in motor which you will understand if you have done sensory, and if there is something in sensory which you will understand if you have done motor. तो ये थोड़ा सा क्रॉस लिंक्ड है. So let us start. I'm going to be muting this and we'll put a timer for 15 minutes, and I'll talk to you all in 15 minutes. I actually don't believe in Pomodoro techniques and all. I feel like टॉपिक वाइज पढ़ना चाहिए, जितने देर में तुम्हारा टॉपिक कंप्लीट हो रहा है. बट just for the sake of keeping this live small and not exceeding the time limit, we will do for 50 minutes. यार एक सेकेंड यार, मेरे आईपैड में अगर लाइव हो जाता ना तो इट वुड बी मच मोर कन्वीनियंट फॉर मी, बट ठीक है, कोई बात नहीं. Okay, 50 minutes starting now. No distraction guys, no distraction. I'll be muting this. guys, just got a call. अरे यार, देखो इस लाइव का यही प्रॉब्लम होता है कि आई कैन नॉट डू इट ऑन माई फोन बिकॉज आई कीप गेटिंग कॉल्स एंड नाउ आई कैन नॉट आंसर दिस कॉल. यार एक सेकेंड रुक जाओ. Okay, hold on. I'm going to text them. ठीक है, this is handled. Let's go back. गाइज मुझे बोरिंग लग रहा है, तो आई एम गोइंग टू टीच यू समथिंग. देखो, इस चैप्टर में कहानी लिखी है बहुत सारी रिसेप्टर्स के बारे में है. पक्सीनियन कॉर्पस्कल, मीजनर कॉर्पस्कल, मर्कल डिस्क, रफनी एंडिंग, क्रॉस एंड बल्ब एंड हेयर फॉलिकल एंडिंग्स. बहुत ही ज़्यादा डिटेल में दिया है इसमें द स्ट्रक्चर्स एंड whether they are slowly adapting or rapidly adapting, whether the piercing of the afferent fibers are myelinated or not, whether they're present on glabrous skin or hairy skin. So let's just remember rapidly adapting ones and the slow adapting ones. The slow adapting ones are Merkel disc and the Ruffini endings. So we're just gonna do one thing. I'm just gonna take this post-it and I'm just gonna write slow. The slow will be Merkel disc and Ruffini, and your fast adapting ones would be which are the fast ones? Puccinian and Meissner. Okay. So I've got these. I know this is going to be mirrored. So the green ones are the slowly adapting mechanoreceptors, and the pink one is the rapidly adapting mechanoreceptors. Talking about the slowly adapting mechanoreceptors, we have Merkel's disc and Ruffini endings. So talking about Merkel's disc, first of all, we have to know that there are three types of endings as well. There's an expanded ending, there's an encapsulated ending, and there's a naked nerve ending. So Merkel disc and Ruffini, being slow, they are expanded endings, not encapsulated. Encapsulated ones are Puccinian corpuscle, Meissner corpuscle, and cross end bulbs. Okay, so we'll talk about the slow ones first. Okay, Merkel disc. They are the most superficial mechanoreceptor, and they are present everywhere. You could find it on your non-hairy skin, let's say your forehead, your glabrous skin. Glabrous means non-hairy, and your hairy skin as well. You could use your beard, or you could use any hairy part of the face or hand. So Merkel disc is the most superficial. This could come as a question. The most superficial mechanoreceptor is Merkel disc, and they are present on both hairy and non-hairy skin. Then their structure. The structure, they are a flattened termination of primary afferent axons. So Merkel disc is a flattened termination ending of primary afferent axons. Their fibers are myelinated, but they lose their myelin sheath before ending the epidermis. So one thing we get to know that if we look at, like, this is a common thing happening in both the Puccinian corpuscle, and before it enters the receptor, the nerve, the afferent nerve, is losing its myelination. That's one thing which is common in both Puccinian corpuscle and Meissner corpuscle. So before it enters the receptor, these are the lamellae of the Puccinian corpuscle. There are about 15 to 20 lamellae of Puccinian corpuscle. So before the afferent fiber enters the lamellae, it loses its myelination, and the same thing is happening in the Merkel disc. Over here, you could see that this is a flattened termination of the afferent nerve, and the afferent fiber just goes inside and loses its myelination and divides into. So Merkel disc being the most superficial mechanoreceptors present in the epidermis of the glabrous and hairy skin, and they are flattened termination of primary afferent axons. The fibers are myelinated but lose their myelination as they enter. Then the Merkel cell along with Merkel disc are combinedly known as, so first of all, Merkel disc will break into Merkel cells. This is more of anatomy wise, but the afferent ending branches to form cup-like flattened structure called flattened Merkel disc. These will synapse with special modified cells. What are the special modified cells? The Merkel cells. The Merkel cells along with the Merkel disc, these together are known as Merkel's apparatus or Igidome apparatus. The name Igidome is given because they elevate the epithelium of the skin, since they are the most superficial ones. Right. And they are slowly adapting mechanoreceptors. They are going to sense what? Touch and pressure. Vibration is not mentioned over here. So touch and pressure. The function of the associated Merkel cells are not clearly known. Because the Merkel cells form a synaptic junction-like structure with Merkel disc, they are assigned the role of primary electromechanical transduction. Not required. Okay, Ruffini. Ruffini is again, one thing about Merkel was that it was superficial, and one thing about Ruffini is that it is the smallest mechanoreceptor. It is present in the both glabrous skin and the hairy skin, similarly as the Merkel disc. The similarity would be that they are present in both the Merkel is present in both this type of skins, and Ruffini is also present in both the type of skin. But the difference is that the Ruffini is the smallest mechanoreceptor. Structures. They are the expanded endings that was flattened. This is the expanded ending of afferent A beta nerve fibers. The myelinated nerve fibers and its unmyelinated ending branches out to form a complex expanded structure. Function, they are slowly adapting that usually receive the sensation of crude touch. That's all we got to know about Ruffini ending. The fast adapting ones would be the cross end bulb and Buxinian corpuscle. Buxinian corpuscle, highly, civilized, or highly, I would say, developed, because they are used for vibration as well, touch as well, and pressure as well. And the structure would include the concentric lamellae of the Buxinian corpuscle, like an onion, 20 to 70 lamellae in each corpuscle. And the largest mechanoreceptor is the Buxinian one. The smallest were the Ruffini endings. And the A beta fibers, again, the same story in every kind of corpuscle, that the fiber is myelinated, but the ending which lies in contact with the lamella of the Buxinian corpuscle is unmyelinated. That's it. Let's talk about receptor potential. Receptor potential is quite important. एक सेकेंड, मैंने बोला था 4 मिनट, कितने मिनट रह गए? वो 10 मिनट रह गए. Let's wrap this up quickly. So receptors convert environmental energy into action potential in the sensory nerves. ठीक है. On application of stimulus, there is a change in energy. A potential change is observed in the receptor. This is usually a non-propagated depolarizing potential. This is a word, a stanza, which I think would be important. Non-propagated depolarizing potential that resembles an EPSP, excitatory postsynaptic potential. This is known as a receptor potential or generator potential. Receptor potential is the same as generator potential, and it is an EPSP. It's non-propagated depolarizing potential. Depolarizing means it is excitatory. So non-propagated depolarizing potential of the receptor. So when the stimulus intensity is increased, the magnitude of the potential is proportionately increased. So when it reaches about 10 to 15 millivolt, the action potential is generated in the sensory nerve. Got it. So the Buxinian corpuscle, due to their large size, are the best studied receptors for studying the genesis of receptor potential. Buxinian corpuscle being large, smaller were the Ruffinian ones. Ruffini endings. Okay, Buxinian corpuscle, they are large due to their large size. They are the best studied receptors for the genesis of receptor potential. It has been experimentally observed that for the generation of receptor potential, the lamellae of the Buxinian corpuscle are not required. It is the unmyelinated nerve terminal that generates the receptor potential. Okay, so the lamellae, which represented the onion-like structure or shape of the Buxinian corpuscle, turns out we do not require it, because the unmyelinated nerve terminals that generate the receptor potential. So the unmyelinated nerve terminal, remember myelination was lost, so the nerve fiber now is unmyelinated. So we do not require the lamellae of the Buxinian corpuscle, we require the unmyelinated nerve fibers that will generate the receptor potential. It is further observed that the receptor potential forms action potential in the sensory nerve at the first node of Ranvier. Important. So the receptor potential gets converted into action potential in the first node of Ranvier, which is located in the lamellae of the Buxinian corpuscle. Mechanism of generation, the genesis of receptor potential. So the pressure on the Buxinian corpuscle. Buxinian corpuscle most extensively studied due to the large size and vibration touch pressure. 3 important things. The pressure on the Buxinian corpuscle causes mechanical distortion of the lamellae. Okay, distortion of the lamellae, which opens up stretch sensitive sodium channels. Oh god, I'm getting another call. 1 second. The pressure on the Buxinian corpuscle, since the mechanoreceptor pressure, obviously. So it is going to distort the lamellae and open the stretch sensitive sodium channels. Influx of sodium would lead to production of receptor potential, and at the first node of Ranvier, the action potential is generated. Simple thing. The magnitude and frequency of action potential is proportionate to the intensity of the stimulus. Okay. Then we talk about the properties of receptors. This is the last topic, and this would include a lot of headings. So properties of receptors, it is important because this was like paid more importance in class. Specificity. The receptors are specific to a particular type of stimulus. So these would include pain receptors, are stimulated by the application of painful stimuli, and touch receptor by tactile stimulation. Touch, tactile, pain stimuluses. Adequate stimulus. The particular form of energy to which the receptor is most sensitive is known as adequate stimulus. I think we have done this in the beginning of the chapter as well. So the particular form of energy to which the receptor is most sensitive, okay, that would be the adequate stimulus. Adequate stimulus for rods and cone is the light. Then what is adaptation? So when a stimulus of constant strength is applied continuously to a receptor, the frequency of action potential in the sensory nerve decreases. This is the basis of rapidly adapting ones. So this is called as adaptation or desensitization. Based on these properties, the receptors were classified into two, right? Phasic and tonic receptors. So phasic ones are the ones which adapt very rapidly. So these are known as phasic receptors, example touch pressure receptors. And tonic receptors are those which adapt very slowly. So phasic ones are adapting fastly, tonic ones are adapting very slowly, or do not adapt at all, are called as tonic receptors. Example, the baroreceptors present in the carotid sinus and the aortic arch of the pain receptors. Okay, so baroreceptors which were present in the carotid sinus. I'm not in the middle. Just realize that in between of the stream. Sorry. So yeah, phasic receptors and tonic receptors. As the name says, phasic, they are very fast, and their examples would be touch and pressure. And the tonic receptors, one of the best examples would be your chemoreceptors and your baroreceptors. So these are your adaptation. Then equity. The precision of stimulus localization is called as equity. The precision of stimulus localization is called as equity. So it depends on the number of receptors present in the area where the stimulus is applied. Okay. Number of receptors increases, your acuity or your precision increases. Intensity. When a stimulus is applied, a receptor discharge depending on the strength of the stimulus. When the stimulus strength is less, the receptors that are present close to the side of the stimulus and receptor with low threshold discharge. When the stimulus strength is more, the activated neuron fire at more rate, and receptors that are present some distance away from the stimulus also discharge. Okay, this is known as receptor recruitment. This is very basic concept. So let's say your discharge of a motor neuron, sorry, not a motor neuron, a discharge which leads to, so why am I saying discharge? I meant stimulus strength. तो अगर हमारा stimulus strength कम होगा, so the discharge which is going to be given out by the receptors are going to be localized in that small area. But if the stimulus strength is more, that is going to recruit all the receptors which are present towards the periphery as well. The Weber-Fechner law. Okay, the magnitude of sensation felt is proportional to the log of the intensity of the stimulus. Important. I think we should write it down. So, what is the Weber-Fechner law? So, according to the Weber-Fechner law, the intensity of sensation is proportional to log of the the intensity of the stimulus. Okay. So this is technically what it says. So I hope you can read it. The Weber-Fechner law would say that the intensity is directly proportional to log of the concentration of the stimulus strength. Then we talk about the law of projection. So no matter where a specific sensory pathway is stimulated along its course to the cortex, the sensation formed is referred to the location of the receptors. This is known as law of projection. Okay, wait 1 second. So no matter where a specific sensory pathway is stimulated along, okay fine, so maybe we're talking about the whole pathway, the receptor, the the nerves which take it to the spinal cord, say ascending nerve, and then the motor cortex. So wherever the sensation formed, it is referred to the location of the receptors. This is known as law of projection. This means irrespective of the site of application of the stimulus in the sensory pathway. Okay, wait, hold on, guys. Guys, we have run out of time. The timer is. What I'm gonna do, I'm gonna give me 10 more minutes because I feel like if I leave this chapter at this point, I'll never be able to complete it. I'll do this for 10 more minutes. Ruk jao. Guys, we're going to start a 10 more minute timer, and this is why I don't like doing Pomodoro, क्योंकि मेरा बीच में टॉपिक रुक जाता है. Anyway, हम लॉ ऑफ प्रोजेक्शन की बात कर रहे थे. तो आई रेड द एंटायर थिंग. दिस इज फॉर, देखो सारा important and the exciting part of the chapter is always given in the end, and this is why I don't like putting a timer when I study. Anyway, so this forms the basis of phantom limb. So let's say there's a gangrene or a road accident, you have to amputate a limb. So you do that, and after some years, a few years later, the patient comes to you and he complains that he feels a pain or kind of itch in that limb which is not there now. This is due to the law of projection. So technically, if I speak, I need a page. So let me just draw and then I'll show you. So we have a person, and we have amputated one of his hands. ठीक है. तो जो हमारा सेंसरी पाथवे था that is the spinal nerves. First of all, the sensory nerves. The sensory nerves would take it to the spinal cord, and from the spinal cord is going to go to the brain. Right. So this is a basic diagram you could study from. If I'm amputating this person's hand, and this is the entire sensory pathway, so we technically remove, let's say, this part of the limb, right? So this part is cut off. So whatever is remaining, all of this is remaining, right? So if there is any kind of stimulation, this could be anyway. If there is any kind of stimulation in this sensory pathway, this would lead to the feeling that the person is getting touched, or he's feeling pressure at the limb itself. Like, let me try to rephrase it once more. Let's say the person feels like his hand is being touched, or he feels vibration in his hand which is not there now. That is mostly because this sensory pathway is getting stimulated, and this is specific because this sensation is going to be referred to the location of the receptor, and that is why he might feel like he's having a itch or a pain in that part of the limb which is not there anymore. So this sensation is getting referred to that receptor. This is the main crux of this law, or the law of projection, is that no matter where a specific sensory pathway is stimulated, no matter where a specific sensory pathway is stimulated along the course to its cortex, the sensation formed is referred to the location of the receptor. Okay. This is known as the law of projection. So this means, irrespective of the site of application of the stimulus in the sensory pathway, the sensation evoked is felt at the nerve ending. Like, if my hand is not there, if I'm trying to feel any kind of sense, like if I'm touching this part of my shoulder, right? So I might feel some kind of sensation in my amputated limb, because the sensory pathway might be running through this pathway. So if I'm kind of like stimulating this pathway, I might feel something which is the receptor of that present over here. So I might feel some kind of sensation over here, or pain. So this is phantom limb. Then we talk about doctrine of specific nerve energy. So the sensation evoked by a stimulus that generates impulse in the specific sensory pathway depends on the precise area of the brain that is eventually activated by the stimulus. Okay. This was first described by Muller. Therefore, it was called as Muller's doctrine of specific nerve energy. For example, when the sensory fiber for touch is stimulated anywhere along its course to the cortex, the sensation evoked is touch. Okay. It becomes possible because the pathways are specific and discrete from the sense organ to the cortex. Therefore, when a nerve pathway from a particular sense organ is stimulated, the sensation evoked is that for which the receptor is specialized, no matter how or where the pathway the activity is initiated. Okay, kind of confusing. I have to read it once again. Let me just skip this part and reach to the last two properties, sensory unit and receptive field. So sensory unit is defined as a single sensory axon and all its peripheral branches. Okay, sensory unit. Single sensory axon and all its peripheral branches. That is a sensory unit. And what is a receptive field? A receptive field of a sensory unit is the area from which a stimulus produces a response in that unit. Okay, so it is that area in the whole sensory unit ka, it is that area in which the stimulus will produce a response. So usually there is some degree of overlap in the sensory unit of the nearby regions. Okay, recruitment of the sensory unit. Receptors spread over a large area are activated when the strength of the stimulus is increased. Okay, this not only activates the sense organs that are in direct contact with the receptors, but also the sensory unit present in the surrounding area. This is called as recruitment of sensory unit or receptor recruitment. Okay, so this was basically the thing which I had explained earlier. So if your degree or if your intensity of your stimulus increases, that would lead to receptor recruitment. That literally just means that if the receptor का stimulus energy is increased, the intensity of the stimulus is increased, so the receptor now will be recruited more, like the peripheral receptors will also be recruited. So this is known as recruitment of sensory unit. Let me just quickly run back to doctrine of specific nerve energy. The sensation evoked by a stimulus that generates impulse in that specific sensory pathway depends on the precise area of the brain that is eventually activated by the stimulus. This was first described by Muller. Okay, so it depends on the precise area of the brain that is eventually activated by the stimulus. So at any point wherever the stimulus is getting activated, wherever the receptor is getting activated by stimulus, I'm sorry, so it has a precise area in the brain, okay, that will eventually activate the stimulus. This was described by Muller, and therefore it is known as Muller's doctrine of specific nerve energy. So that just means that, for example, when the sensory fiber for touch is stimulated anywhere along its course to the cortex, the sensation evoked is touch only. So it will not change. The sensation would not change. So the whole thing, the same thing. Like if over here, if I'm touching on the whole sensory pathway, if I am stimulating anywhere in this pathway, the sensation would be touch. So it becomes possible because the pathways are specific and discrete. Okay, ठीक है, चलता है. So I understood these two examples. That is, the sensory fiber for touch is stimulated anywhere along its course. The sensation evoked is touch, and it becomes possible to because the pathways are discrete and specific. Therefore, when a nerve fiber, hold on, guys. Am I getting a call again? Therefore, when a nerve fiber pathway from a particular sense organ is stimulated, the sensation evoked is that for which the receptor is specialized. Okay, so the sensation evoked is that for which the receptor is specialized. So if this is a touch receptor and I am stimulating the touch receptor in between this pathway, the sensation which is being evoked, that is touch. It cannot be pain or it cannot be heat. So this was doctrine of specific nerve energy, and that brings us to the end of this introduction of the sensory unit. Quite interesting. I feel like law of projection and doctrine of specific nerve energy were the major important parts which took a lot of time in understanding. Let's just take a break. Timer देखने दो मुझे. Okay, 33 seconds more. I'm closing the timer now. Stopping the timer now. Let's just take a break and we'll be back to studying for biochem and anat. back. I'm back. Uh, we will be doing बायोकेम ना, और बायोकेम में हमारा मॉलिकुलर बायोलॉजी चालू हुआ है. ऑनेस्टली बहुत ईजी है. आई एम लविंग इट. एंड द ओनली रीज़न आई एम सेइंग दिस इज बिकॉज हमने नीट में पढ़ रहा. सॉरी, द ओनली रीज़न आई एम सेइंग दिस बिकॉज हमने नीट में पढ़ रखा है. तो let's try to wrap this up in 30 minutes or 25 minutes. I'm gonna put a timer. अब मेरे को टाइमर लगा के पढ़ना पड़ेगा क्योंकि बिकॉज ऑफ दिस लाइव स्ट्रीम इट्स मिसिंग अप. मैं तो बोलते जाऊँगा इसलिए. ओके, 25 minutes and counting. I'm going to mute this because ये सुनने की ज़रूरत नहीं आप लोगों को. बाय बाय. ओके गाइस, बायोकेम पढ़ लिया है मैंने। आज जो कॉलेज में हुआ था वॉज अ वेरी स्मॉल टॉपिक, तो उसको कंप्लीट करने में ज़्यादा टाइम नहीं लगा। आई रेड थ्रू द स्लाइड्स and I read the book as well. I think I'm going to end the stream right here. Thank you for joining, and let's see आगे मैं कितने streams करता हूँ। मुझे नहीं लगता मैं इतना consistent रह पाऊँगा, but thank you for joining whoever did join. Bye bye.